Okay, so welcome back. Now what we're going to do is I'm going to walk you through an example of how to prove a limit using the delta epsilon definition. Okay, so this is what we call a delta epsilon proof. This is the precise way of proving that a limit, or of evaluating a limit. Okay, so they want us to prove that the limit as x approaches 1 of this function is equal to 3. Now we know that if we just plug 1 in, we get 3. And if we approach it from the left and we approach it from the right, we get 3. So this is, and we a polynomial. So we know that the limit of this thing is 3, but how do we prove it? That's different. Okay? So we're going to do a formal proof showing that the limit is 3. So we start with our proof. Now, what we're going to do is we're going to start with let epsilon be greater than 0. Why? Because remember, the first part of the proof says that for every epsilon greater than 0, all this other stuff must be true, right? That's what we're trying to prove. So let's just start with an epsilon that's greater than 0. Okay. Now we've got to choose a delta, because again, what we're saying is that for every epsilon greater than 0, there must exist a delta, right, such that if this is true, then this must be true. Okay, so we're going to take it one piece at a time. So let epsilon be greater than 0, and what we're going to do is we're going to choose delta to be, in fact, we're going to define delta in terms of epsilon. Okay? Now this is where we get to choose, right? So now what we're going to do is let epsilon be greater than 0, choose delta equal to epsilon over 2. Now some of you are probably thinking, well, how did you come up with epsilon divided by 2? You'll see. Because part of this is we're going to end up working backwards to figure out what our delta is going to be. Okay, but I want you to show you, okay, we're going to choose delta to be epsilon greater than 0. So guess what? Since epsilon is greater than 0, if I choose delta to be epsilon divided by 2, so half of epsilon, then this is also going to be greater than 0, right? Which is what we want. Okay? Now, so because remember, there exists a delta greater than 0. So now we know that delta is greater than 0. Okay, so now, there are two basic approaches to trying to figure out what delta is. So one method is purely algebraic, and I'll show you that one. Okay? Where we're going to work backwards, and the other one is geometric. Okay? So we begin by tackling the problem from an algebraic point of view. Right? Because, and this is where your scratch work comes in. Okay? This is not part of the proof yet, but you're going to do scratch work. So over here, I'm starting the proof, and let's say I don't know what delta is, right? Okay. So let's say I'm here. I let epsilon be equal to 0. Now, I got to figure out, I know I want to choose delta to be greater than 0, but what should I choose for delta? Okay. Well, I know that my distance, right, from L, so f of x minus L is going to be less than epsilon, right? Okay. And so now what we're going to do is we're going to manipulate the expression, and what's the point? What am I trying to get to? I want to manipulate this expression to get something that has x minus a less than something over here. And what happens is by manipulating this to get to something that has this on the left-hand side, whatever is on the right-hand side of the inequality is going to be what I want to choose as my delta. This is why it's purely an algebraic exercise. Okay, so let's do that. Okay, so now I'm going to fill this in. So that's f of x is this. So I'm going to say I want 2x plus 1 minus L. L is 3 in this case, right? And I want that to be less than epsilon. Now what I'm going to do is I'm going to simplify this thing. So that means I'm going to get 2x minus 2. Absolute value of that is less than epsilon. Okay, now, again, we're dealing with absolute value signs, so you got to make sure that you know how to handle absolute value signs. So now I've got, I want what? X minus 1 in this case, right? I want to get an absolute value of x minus 1. That's my goal, right? There's my a, there's my x, so I want x minus a, or x minus 1 in this case. So now, if I factor out 2, right? So if I do absolute value of 2 times x minus 1, now I see the x minus 1. Now, I can pull the 2 out because it's a constant, right? So the absolute value of 2 is just 2. So I can pull this out in absolute value, and I get 2 times the absolute value of x minus 1 is less than epsilon, and there's where my epsilon divided by 2 comes from, because if I divide both sides by 2, there it is, and there's my delta. And so therefore, absolute value of x minus 1 is less than epsilon over 2, which I'm going to set equal to delta. So this is all my scratch work. Okay? So this is not part of the proof. This is part of my scratch work to try to find delta. Now that I know what my delta has to be, now I can go back to the proof. Okay, so now, notice what I'm going to do here. Now, back. Choose delta equal to epsilon over 2, which is going to be greater than 0. Right? And so now, where do we go from here? Now, this is where it all basically just falls apart and goes in line. Now, here's what we're going to do. Here's where the if part comes in, right? So we let epsilon be greater than 0. We choose delta to be this, right? So again, remember, for every epsilon greater than 0, there exists a delta greater than 0, such that if, what? If the absolute value of x minus a, right, is less than delta, right? So if this is true, then the absolute value of f of x minus L is less than epsilon. So, this is where we're at. So let's do it. So now what we're going to do is, this is a conditional, which means if we assume this is true, then we should get this automatically. This should follow. So what we're going to do is, in a conditional, we're going to assume, right? So we're going to assume 0 is less than the absolute value of x minus a, or excuse me, in this case, x minus 3, oh, excuse me, not x minus 3, sorry, x minus 1 is less than delta. Okay, now, which is equal to epsilon over 2. So now what I'm going to do is, using this as the assumption, watch what happens. So now what I'm going to do is I'm going to multiply both sides by 2. So this is equivalent to 2 times the absolute value of x minus 1, which is less than epsilon, which is equivalent to the absolute value of 2x minus 2 is less than epsilon, which is equivalent to the absolute value of 2x. Now here's where I'm going to manipulate things, right? I want to get to this, right? Well, I've got minus 2, so now let's just do a minus 1, or excuse me, plus 1 minus 3. Right? Or here, minus 1, plus 1 minus 1 minus 2. Let's do that one. Because all I did was add 0, right? Plus 1 minus 1 is less than epsilon. And now I'm going to combine these two, and I get the absolute value of 2x plus 1 minus 3 absolute value is less than epsilon, and I'm done. Because what I just showed is let epsilon be greater than 0. Through my scratch work, I found what my delta needs to be, so I chose delta to be epsilon over 2, so half of epsilon, which is also greater than 0, because epsilon is greater than 0. So I've got this first part, now the conditional. Now it says, hey, if I assume this is less than delta, which is equal to epsilon over 2, well, guess what? It all comes back to the fact that, guess what? The f of x is less than L, the absolute value of that is less than epsilon, and therefore, so I'm at my conclusion, therefore, the limit as x approaches 1 of 2x plus 1 equals 3. And I'm done. And that's it. Now again, I took a long time to go through this, but again, practice this, okay? So part of your work is going to be your scratch work to find out what you need to choose delta to be. Once you know what delta needs to be, and usually it's going to be in terms of the epsilon, because if epsilon is greater than 0 and you define delta in terms of epsilon, then that's the key. Most of the time it's going to be in terms of epsilon. Not all the time, but a lot of times it will. So again, practice. It's going to, once you do some of these, I can guarantee you one thing, there will be an epsilon delta proof as a quiz and definitely on the exam. So you can count on there being at least one delta epsilon proof on the exam. Okay? So you got to practice this. Okay? Practice it. Okay? If you don't understand it or you get stuck on something, reach out to me. I'd be more than happy to help you. Okay? Take care.